Welcome to Industrial IoT Live Lab here on Industry 4.0 So this is a weekly live show where we explore the tools and technologies for building the connected factory. And today we are going to learn about how to use Apache Streampipes for collecting and analyzing industrial IoT data. So please make sure to subscribe, and you can switch on the notifications so that you don't miss any of these shows, or that you'll be notified whenever we go live. Okay, so to help do the presentation today and show you how to use Apache Streampipes, I've got guests here from Bytefabrik. I've got Dominik and Philipp, so I'll let you guys introduce yourselves and then you take over the presentation.
Yeah, so thank you a lot for having us. Great to be here and to be able to show Streampipes. My name is Dominik. I'm a CEO of Bytefabrik.AI. So we are a spin-off from Karlsruhe out of KIT, the university there. And I'm also part of the project management committee of Apache Streampipes. And we started the development of Streampipes many years ago before bringing it to the Apache Foundation. And I'm very happy to introduce Streampipes today and answer all your questions.
Yeah, and also a warm welcome from my side. My name is Philipp. I'm also one of the PMC members of the Apache Streampipes project, and I work as a CTO for Bytefabrik. And I'm really happy to be here today and present you the software and discuss all your questions.
Perfect.
Yeah, so I will present my slides and directly start. So today we'll talk about how Apache Streampipes looks like. Just a second so that I can see any questions. I will just switch over. So great. So we will start with providing a motivation and project overview, and afterwards we will show you a quick walkthrough over the system before we present a feature tour. So the feature tour will present and introduce all parts of Apache Streampipes for connecting data, exploring data, creating pipelines, also how to externally access data using our Python client. And in the end, we also show how to use Streampipes as an application platform for IoT development. So there will be many demos we will show you. And if you have any questions, just write into the chat and we'll be happy to answer them. Starting with our motivation and project overview. So the main background why we started to develop Streampipes is when looking at the smart factory or factories in general, and especially when looking at like large automated assembly lines, what you see is that there are many, many different sensors and also data sources which come from a large variety of protocols, for instance, PLCs, but also specific protocols used in the robotics domain like ROS. You have MQTT, Modbus, so many different protocols, and all of them produce quite a lot of data coming from sensors, from production control systems, and so on. And our goal is, or the question behind our goal is how to make that kind of data accessible for non-technical experts, because usually there's quite a gap between OT people who are very familiar with production processes and the IT space, where data analytics can help to further improve production systems. And that's the main problem behind the development of Streampipes. And the mission statement of Streampipes in the Apache Foundation, you always have like this one sentence that describes the project, and its goal is to provide an open source industrial IoT toolbox that enables non-technical users to connect, analyze, and exploit IoT data streams. So our goal is to support non-technical, non-IT people in the whole IoT lifecycle, let's say, from data connectivity over getting insights up until exploiting data streams. And in form of a toolbox, we provide quite a few different tools that support these different needs, which we will show in this presentation. So some project facts at the beginning. So Streampipes was originally created as part of a research project, a European research project at the SZI Research Center for Information Technology located in Karlsruhe. So after the end of the project, we decided to make the whole open source or the whole project open source. And after we did that, we decided also to bring the project to an open source foundation to further grow the community and to have some community-driven development as well. So we joined the Apache Incubator, which is like the entry path for new Apache projects by the end of 2019. And after 3 years of incubating, we became an Apache top-level project in the end of 2022. So far, we had like approximately 7 Apache releases, which are the official releases of a project in the Apache Software Foundation. And since we started the project as a very small, let's say, group from SZI, we have grown the contributors to currently 14 members in the project management committee. So I think it's people from like more than 10 different organizations and also from many different countries. So it's a very independent project developed by a large group of people from different organizations. And in addition, we have like 12 committers who regularly contribute to the open source project and 23 more contributors. So as an Apache project, of course, we have quite a few integrations with other ASF projects. So first of all, in terms of IoT connectivity, so connecting to PLCs and other production systems, we rely on Apache PLC4X, which is a great library for connecting to industrial data. We make use of eCharts, which is a very nice visualization library for all kinds of visualizations. And of course, there are many connectors to third-party systems, message brokers, but also databases and so on. So these are only Apache projects, but we have a lot of different integrations to other systems and protocols, which we will show later on. So now coming to the system overview. So I've just briefly introduced how the mission statement of Apache Streampipes looks like. But so in general, Toolbox means we have several modules that help users first to quickly connect data without any programming skills. Second, to create like data analytics pipelines that make it very easy to harmonize data, but also analyze data in terms of that pipeline editor, a web-based tool that allows you to quickly create analytics pipelines. And in addition, we have also a few projects or a few modules to visually explore data in terms of a data explorer and a live dashboard that can be used as a tool for monitoring data at shop floor level. From a technical perspective, Streampipes looks like typically we are connecting to data coming from like OPC UA protocols, from MQTT or from like PLCs. And we're using an adapter library that makes it easy to access such data sources in real time. And data streams can be like processed by a variety of data processing algorithms. So there's like a library of standalone microservices that can be used to transform and harmonize data. So there are 2 execution models for data processing. The first one is pipelines, so reusable components that can be orchestrated by users using this web UI. And the second one are functions, which are targeted at developers to easily manipulate data and create data streams. Also, Streampipes comes with an included time series database and a message broker. I will talk more about that in a second. And in the end, users interact with Streampipes in terms of the user interface, which includes tools like the pipeline editor, the data explorer, but also programmatic access is possible using a software development kit for Java and for Python. And for Python, we also provide like a function zoo with some predefined integrations to online machine learning libraries like River. That will also be part of the demo later on. And finally, Streampipes can also like connect to third-party systems in terms of data syncs, where we can connect to external systems like Kafka, RocketMQ, or also MQTT. So a high-level view on the architecture of Streampipes. So when you start looking at the data sources where data typically comes from, there is a library which is like typically a microservice that includes several connectors that can be configured by the web UI. And these connectors directly get data from the PLC or the underlying source system. And data which is collected by this adapter library is then forwarded to the message broker. So the message broker is like the main channel for communication between data on the one hand and also algorithms on the other hand. And Streampipes supports several message brokers. So at installation time, you can choose between like Kafka or NUTS or MQTT. So that's quite exchangeable, that messaging layer. There's also a time series database for storing data coming from production systems. And one layer above, we have like pipeline element microservices. So pipeline element microservices are services that provide some business logic for transforming or analyzing live data coming from the message broker, which could be like trend detectors, filters, other operators, up to machine learning algorithms. And so these different microservices are like orchestrated from a pipeline management component that closely interacts with the web UI on the one hand, but also with the other programmatic tools like the Java client to easily like create pipelines or to analyze data. And these are composed like out of these microservices. Great, and with that I will hand over to Philipp, who will start with the feature tour, and we will start with connecting industrial data sources as a first step to make sense out of data.
Okay, great. I will start with the connection layer. So how can we get data from the machines and from the shop floor into the system? And here you see a brief overview of the architecture. So at the bottom, you can see all the different kinds of protocols which are often used on the shop floor. So this can be OPC UA for newer machines, but also more legacy machines often have PLCs. There we are leveraging PLC4X, for example, to get the data out of the machines. But it could also be other IT protocols like REST interfaces, file uploads, or also an MQTT broker. For all of those different data sources, a user can configure an adapter over the graphical user interface, and then this data is harmonized onto a message broker from where it can be used for later analytics or storing it. And the connection step is always done with individual configuration steps. So usually first you have to decide what kind of protocol you want to connect or what the data source actually is. Then you need to provide some protocol specific settings like the access rights, the frequency you want to read data from the data source. Then for some adapters, you also need to define the format which the data is sent. For example, if it's an MQTT broker, you have to provide, is it JSON or CSV or any kind of other format. And then we model our events. So within Streampipes, we always work on event streams that are time-based, and they have an event schema. And here a user can provide data types and also a lightweight semantic to describe the data, so what it actually means. And all this data, which is added here, will be later used to support the user when analyzing it. And in the end, a user can directly execute the adapter. This is then started connecting to the machine and creating the data stream. And that's what I want to show you in the first demo. So therefore, I switch to a Streampipes instance, and here you can see the whole module. And Streampipes is quite modular. So we have modules for all the different steps you usually need when you want to analyze your data. So here's the connection layer. Then there are also processing pipelines to analyze the data or the live data. And also there's the way to visually explore the data. And I will walk you through the whole process now. So we want to start with the connect library. You can always navigate from the starting point to connect, or also from the left side, you can also navigate to the individual modules. So if I go to connect, you see all running adapters that were already created. And now we want to add a new data source. Therefore, we go to our library, and here you see we can connect Apache Kafka. You can also connect to files. So if you want to play around with the system, you can upload CSV files or JSON files to get started. There's also a data simulator and also other protocols like MQTT, OPC UA, or also if you want to connect to a Siemens PLC, for example, you select the PLC S7 adapter, provide the IP address to the PLC and the nodes you want to read, and then the data stream is created automatically. And now I want to demonstrate this for the OPC UA adapter. So we select OPC UA, and here we have several configuration parameters, which I've already provided or prepared before the talk. So you can always also store those. So if you want to connect similar data sources, you can store such templates, so you don't have to enter them manually. So first you have to decide if you want to pull the data or use it on subscription mode. Then you need to enter the security level. Here we have the URL to our OPC server, and then the system connects to the server, and here you see all the available nodes on the server. So here we have a leakage test station with multiple nodes, and now I want to connect all of them, so I select the whole test station. In the next step, you see our event schema. So internally, the data is transmitted over JSON, for example, but also a user can define what kind of serialization is used in the internal message broker. And the first message that you see here is that a timestamp is missing. So each event which is coming into the system requires a timestamp. So if the data source doesn't already provide it, we can add it here. And now a new timestamp is added. You can also see all the live transformations here in the live UI. So you see how the data is actually changed. Then also, if you want to see what the temperature actually means, you can provide description and also the data type, which is shown here. And now you can also transform this data. For example, if this is in degree Fahrenheit, you can transform it to degree Celsius, for example. I have to move this here and save it. And now the data is on ingestion already transformed. Once you're done with changing the event schema, you can go to next and can give it a name. And now you can decide if you only want to connect the data, so you hit run adapter, but you can also directly persist it in a time series storage for later online analytics. So if I click that, the data is put onto the message broker and also to the time series database for later offline analytics. So if I now click on create start adapter, you can see here the live data, and that's how you can get data into the system and start working with it and analyzing it. So if I go back to this, yeah.
Sorry, just a quick reminder to our audience here, if you've got any questions, please feel free to post them on the chat here, and then we'll have them answered directly. We're coming to you live, so we'll be able to get your questions and answer them. So please go on.
Okay, thank you. So I go back to the slides. And so now the first step is done. We have connected to our data source and have it into the system. And then usually the next step is to visualize it, or like first visually explore the data to get a better feeling for it or understand it and find first situations in the data. And there are two different ways to do that. First of all, there's the live dashboard, which you can configure and put on the shop floor, for example, to monitor some live KPIs or live sensor data. And then there's also Data Explorer, where you can really do a deep dive into your data. And also with a few clicks, you have the chance to see what is going on in your machine, find situations which you want to automatically later on monitor on the live data. So for the Data Explorer, it's similar to connecting data. It's always like a widget-based step-by-step. So first you create a data view where you want to put all your visualizations. Then you configure the data sources and the visualizations. And then you can also choose the time range when you want to look at the data. And there are multiple different visualization types. So for example, you can present it as a table, you can put it into a heat map or in a time series plot, but there are also like first simple analytic steps. So if you want to see a distribution or also correlation between sensor data, you can go to the Data Explorer and do it right there. And I also want to show you this in the live demo. So on the left, we have those two modules, so the dashboard and the Data Explorer. I will only briefly show you the dashboard so that you see how it looks like. So here, all this key parameters can be configured, and then you can also put this dashboard, for example, on a big screen and showcase it somewhere. So it's only for consuming the data. Additionally, we have the Data Explorer, and here you can see already some visualizations that I've provided. So here we have the data which we connected before. So it's a flow rate sensor, temperature sensor, and here user can, for example, go into the data, so just store it, see how do the values develop over time. You can also select different time ranges. So if you're interested in 1 week ago, you can select it here, or 1 hour. And here you see then the data, and all the charts are updated live. This data can be viewed here in this dashboard overview, but we also have like a PowerPoint-like style, so you can also provide them as slides. So if you want to, if you find an interesting scenario, you can also put it like this and then discuss it with your colleagues or with other people and see how the data looks and work with the data. To create a new view, you click on Edit Dashboard and say you want to add a new widget. And then in the first step, you need to create the data source. So here we have a flow rate sensor, and then you get all the query parameters here. So you see kind of properties we have, so we can select all of them, for example. And in the first step, we want to only view add them in a data table. So maybe since my screen is not so big, I will deselect some of them. And then you can create your own visualization. So if we go back to the data, so see, okay, we get the raw data, but maybe that's too much to look at later. We can also aggregate it. So usually here one day, but let's say, okay, we want to get an event for every second, and then or every 15 seconds we want to get an event. And so you can prepare your data for later analytics. You can also add filters if you're only interested in several situations, or if some thresholds are like, if the value is higher than a certain threshold. And you can also quickly change the layout. So here, for example, if you want to see it in a time series chart, you can select it. Also maybe deselect one or two of them. Then there's different possibilities to view at the data. So you can have a scatter plot or a bar chart. And that's a way how you can quickly create your own visualizations. And once you know, once you're ready or once you're finished with creating the visualization, you can store it, and then it's part of your data view. So that's usually the first way to get to work with the data and also quickly explore it. So now we have created data, we have stored it in our time series database, and we have, for example, found a situation that we want to detect. And therefore, we have analytics pipelines, which are a graphical flow-based editor to work with the data, analyze it, and, for example, find patterns in the data. And here you see an overview. So on the left, you can see a pipeline always consists of 3 different parts. So we have data streams. So those are the connectors that we've created before. Then there are multiple processors to work with the data or transform the data. And in the end, there are data sinks. So those can be internal databases or notifications or third-party systems where you want to push the data to. So for example, if you have an internal database or a Kafka cluster, you can also use Streampipes to connect to your data sources, transform it, detect patterns in the data, and forward it to Kafka, for example. To create a pipeline, you have to choose the data streams you want to work on. So you can select one or multiple of those data streams. Then you need to choose the processors and data sinks to transform the data, configure all the elements, and then you can directly start the pipeline. And the goal is like to have a flexible way to harmonize and analyze the data stream with only a few clicks, and find the insights or get to the right situation that you want to detect on the shop floor or to understand what is going on. And the approach is to have a drag and drop like interface where you can connect to different algorithms and transform the data and forward it. There's also a verification service. So a software developer who's providing those algorithms can say what kind of data is required. So first of all, what kind of data type, but also if you need a specific unit or a specific sensor type, this can be configured. And then if a user tries to connect a data source that is not compatible, he or she will get an error from the system that states, okay, this is not compatible, you need another kind of data source, so that you don't have semantic, or there's a semantic type checking in the background. So I will also show you this. Yeah.
Yeah, I've got a question here from Alexander, if I may. So sure. Alexander is asking how to handle the settings to store, export them. So I guess he's asking if it's possible to, yeah, sure, go on.
Yeah, I will. There's a way to do that. So I will. There is also a way to model the assets. So, for example, if you want to develop or connect your machines, you can say, here I have a new machine, and then you can also say what kind of resources are linked to this machine. So here, for example, the OPC UA demo or the dashboard, and you can update the links and store it. And this is then used in the settings. You can then export it. So here you say, okay, here, this is the new machine. which I just created, and then you can export it, and this contains all the configurations that you've done before, and you can import this into another system to work with the data again.
And you can also directly export data from the Data Explorer, Philip?
Yes, sure. So if that what I just said is only regarding the configuration of Streampipes and connectors and the pipelines. If you're interested in the data, you can also export this. So in the Data Explorer, for each widget, you have the possibility to download the data. So you can say you want to download all of the data, or only if you only want to get the data from a specific time interval. And then you get it as a CSV file, for example, and can download it onto your machine, so you can also get access to the data. There's also a second way with a programmatic interface, which I will show later in the demo.
So there are basically many different ways to export data, and also data sinks, which will be part of pipelines, can be used to forward data to external systems, and that's what you will probably show in a second.
Exactly. So is your question answered?
Yeah, so Alexander, let us know in the chat if your question has been answered. Otherwise, you can proceed.
Okay, thank you. So I will now move to the pipeline view, where we have the chance to work with live data. So here you see the different data that we've connected. So the flow rate sensor, for example, again, you can also directly see what kind of data is coming here. So here you have the description and also the live values that is coming from the data. Then there are different data processors. So you can, for example, different mathematical operations, or also operations on arrays. So you can basically transform the whole data. All those algorithms are provided over a software development kit. So also during runtime, you can integrate your own algorithms and extend the system like that. And as Dominik just mentioned, there are also different data sinks. So here, that's another way to get to the data. So you can, for example, publish it to Kafka or to MQDT, or also directly to a database. So if you want to store the data stream to a Postgres database, you can also only drag and drop it in here and export the data that way. For this demo, I want to show you how you can also create notifications. So within the data stream, we have a temperature. And if this temperature drops in a short amount of time or a short period of time, we want to notify someone. So therefore, there's the trend detection. And if I select this and connect it, then a user can configure it. So here you can say what kind of property you want to observe. So in this case, the temperature. Then we want to see if it decreases by, let's say, 80% in 2 minutes or in 102 seconds. We want to forward the whole event to the next component. Then we can also, for example, split the data or send it to other events. You can also always enable the live preview, so you get the live data. So if this rule is activating, you can also get the data here. That's a way to debug the pipeline and to see if the rule you're creating is actually working the way you like it to work. Then in the end, we have the data sink. So you can, as I said before, store this information in a database, but it's also possible to send notifications via email or also an internal notification service. So if I connect this, then I say alarm, and then I maybe say, okay, value to low, and you can also encode the actual temperature value. So this will be replaced with the value, and then you can save it. And that's basically how you create your own analytics pipelines to analyze the data and work with it. Once the pipeline is completed, you can save it and execute it. And now all algorithms are started, and you can also see here the details. So as Dominik showed before, behind those pipeline elements, there's microservice architecture, and they don't necessarily need to run on one PC. You can also distribute the whole system. So going back to the slides, I will also want to show you how you can use this data in an external system. So recently, we have also provided Python support because we've been asked quite often, how can we get the data into Python, train our machine learning models, and also deploy the machine learning models on the sensor data. So there are different ways to get the data out of the system. So on the bottom, we have our data sources again, and then the Streampipes IoT data infrastructure. And then, as I showed before, you can export it over the graphical user interface. Then you can also use different data sinks to provide the data to the other third-party systems. And you can also use a Java client or Python client to connect to the platform API and also work with the different resources. So you can also start and stop pipelines, but you can also get data out of the system, and you can also get the live streams without knowing about the technical infrastructure. So you don't need to know about internal message broker or what kind of technology is used internally. You can only use your software development environment, for example, a Jupyter notebook, and work directly with the data. And here, there's also a platform API. So you can also extend the platform and provide your own applications. And yeah, as I stated before, you can change the pipeline lifecycle. You can also modify the pipelines and provide live data to external apps, or also get the historic data, which is already stored in the internally used time series database. Here is a short example for the Java client. I will give a live demo of the Python client in a minute. But here you can see we have a main method. You only have to provide the credentials. So what is the endpoint of the system, and also an API key that you create in Streampipes. And then you can use this client and get, for example, all pipelines which are running. You can also start pipelines. And here you get all the data streams, and you can also subscribe to those data streams to get the live data into your programming environment. And the same, it's also we have also for Python. So Streampipes now, since the last release, integrates quite cool into Python. And now you can install the library with pip install. There's also all the documentation you can find on our website. And the goal of the client is to easily interact with the Streampipes API that often also use the data historian, so all the data of your machine that is stored. And you can't only consume the data, you can also create your own functions and deploy them so that you subscribe to a data stream and process the data within Python, create your own models, for example, and or online machine learning bibliotheques like River, and transform the data that way. And now I want to show you this. So I go back to our system, and here you can see the different pipelines or the different data sources or data streams that we have. And if you go here to the user preferences, to the profile, you can create a new API key. So I provide a name and create an API key. Then I have to copy this string here. Now I go to my development environment, and here I have already provided a small example. So first of all, I have to provide this API key and create my Streampipes client here. So I execute this cell, and then we get an answer, successfully retrieved all resources. So it states that we are connected to currently to a local instance, but you can also connect to any instance. So when it's running on a shop floor, on an industrial PC, or also if you have installed a system in the cloud, you can directly access it here over this API. And we have 2 data lakes measurements that are stored, and also 2 data streams. To get all this information, we can now have a look at the data lake measurement API. So I have to make this cell a bit bigger. So here you can, like this, you get it in JSON, and you can always also transform it to pandas. And then you should see the data here. Maybe I have to change the view. So if I execute it again. Okay, I don't know why, but usually you should get all the data lake measures that you have. So for example, if you want to see the data, so we have this flow rate sensor here. You usually would see also a table where you see what kind of data sources you have within the system. And then you can directly access the live data. So here you see the timestamp and all the values that you have accessible. And this is already provided into a data frame, into into Python. You can also look at all the live data. So if I go on here, we see the different data streams, so the flow rate data stream and the OPC UA demo that we've created. And in the next step, we want to train an online machine learning model to predict the temperature of our event stream based on other values. So therefore, we have to copy this element ID and go to the next cell. And this is also an example from our documentation. So what we do is we create such a Streampipes function. We read the data, train a classifier or regression model, and predict the temperature based on the other features from our event stream. So if I go here and replace the string and execute the method, it'll take a second. Now it registered the function at the system. And if I go back to Streampipes, back to my browser, and go to the pipeline editor, we have a new data source with our prediction. So we can also look at the live data that is coming in. And here we have our predicted value and the actual true value. And over time, this prediction will get better. So I will visualize it and store it, therefore, into the database. Therefore, I select the data lake, connect it, and say prediction, and save it. Execute the pipeline. And then we can see over time how the prediction is getting better and the actual value is predicted based on the other sensor values. So if I go to the Data Explorer, edit it, and add a new view here, I can select the pipeline with the prediction service. Now I want to get the predicted value and the actual value. Click on Next, select the time series, and create this visualization. And now you get the live data. And over time, you can see that here the prediction was not that good, but it gets better over time. And it learns that pattern from the data and sends it back to the system. So that's a quick way to also train your online machine learning models and get the results back into the system. And now you can provide this data, for example, to your customers and show them new insights to the data. You can store that as well. So now, do you have any questions?
No questions. We can
no
proceed.
Questions? Okay. So then I will give back to Dominik. Then he can continue.
So thank you, Philipp. So I think the Python client is a great way to interact with Streampipes. So the same is also possible with Java without these online machine learning tools, which we only have for Python, because there we have that huge universe also of like PyTorch models or other things that we can integrate. And as you've seen, they are integrated like as a Streampipes function. And in the next part of our talk, I would like to talk about how we use Streampipes as an, let's say, application development platform for IoT applications. And I will show that based on an example. So in general, there are several ways to extend Streampipes. The first one is like extending Streampipes with business logic. So business logic is like anything that you've seen in the demo, for instance, new adapters. So in case you have some proprietary protocol for machine connectivity, you can create a new adapter using a software development kit, and that can be installed at runtime without restarting or reinstalling the system, thanks to the microservice architecture. So it's really easy to extend the system to your additional needs. And the same also accounts for data processors and data sinks. So these pipeline elements that you've seen, in case there's some proprietary algorithm for a specific machine that you would like to develop, then the SDK can be used to also extend Streampipes with more functionality. And what we've seen in the last demo is like the concept of functions. So functions are very similar to data processors, with the exception that they just run in the background without being available as a pipeline element. But functions, for instance, can create data streams that you can then use in the pipeline editor, like the prediction value, to run anything related to data analytics in the background. So that's like how to extend business logic. And besides that, sometimes you would also like to enhance the user interface. So for instance, if you would like to implement some health monitoring application of a specific engine or something, or a specific device or machine, you can also develop a custom user interface that can be directly integrated into Streampipes. And that's what I will show in a second. So starting with the software development kit. So as I said, the goal is to extend Streampipes with additional pipeline elements, which could be adapters, protocols, or data sinks. And we provide a Java-based SDK. And also for Python, we currently support function development, not yet pipeline element development. That's currently only available in Java, but we are working on providing that in Python as well. So when you, let's say, create a new data processor, so a new pipeline element that can be used by users, typically these pipeline elements, so as you've seen with the trend detection component, provide some user input that is required, like the threshold or the time window of the trend that should be detected. And basically, a pipeline element can be developed using this example here on the right. So basically, you need to implement some data processor interface, and then users or programmers can provide like 4 implementations to 4 different methods. The first one is declare config. That's where you provide the configuration of the pipeline element. So you say what kind of data is needed. For instance, for the trend detection, if you want to monitor some numerical value, you can provide a requirement that any data stream that connects to this processor needs some kind of event that includes some numerical value. But you can also like request that you need some event that has only temperature values or only acceleration values. And then you provide the user configuration. So the software development kit provides several ways to define the required user input. So if you would like to define a text input or some selection, or also like some code input, that's possible to define here. And then also like there are 3 other methods. The first one is called onPipelineStarted. So that is being called actually when the user starts a pipeline that makes use of that pipeline element. So you can like create database connections or whatever is needed upon start of a pipeline. And then there's an onEvent method that is called every time an event arrives. So that's where you put your business logic basically of your own data processor. And in the end, there's an onPipelineStop method, so which you can use to clean up anything, because that's called when the pipeline is stopped. That is part of the pipeline element. So to make it really easy to extend Streampipes with your own functionality, we also provide Maven archetypes and also like several notebooks for Python that show how to create a new data processor. So pipeline elements show up in the user interface directly after you started them, so they can be dynamically installed. There's a view in the UI and that allows you to find new pipeline elements and to directly install them. So that's like the first step. The second is using user interface extensions, and that's also, yeah.
Sorry, Dominik. So maybe before you go proceed with that, so we've got another question here. So I'm not sure if you've already answered this one from the previous slides, but the question goes, as a software developer hoping to bootstrap the Streampipes, how flexible is it to customize and build custom pipes programmatically?
Yeah, so it depends on what you would like to do, but it's quite easy to customize it. So if the question is how to like bootstrap Streampipes, so what we sometimes do is like we create pipelines and adapters and so on, and then use this export function, which creates basically an application package file of Streampipes that you can just import in another instance, for instance, of your customer. And then it directly runs all the pipelines, provides all the dashboards and data explorer views. So that's like how to easily implement or bootstrap Streampipes basically, in case you would like to transfer some parts into another instance. What you can also do is you can create functions programmatically. So for creating pipelines programmatically itself, so that's something which is not in the scope of this software development kit, because pipelines typically are created flexibly by users. So you can export them and import them to other instances. But since Streamers under the hood checks any data stream that is connected to any algorithm and computes also the output of every component, that's something which is the goal, to let this be done by users in the UI. In case you would like to programmatically do something, you can use these functions, which can be completely flexibly implemented using the Java client or the Python client. So I hope that answers. Philipp, yeah, you have to.
Yeah. I wanted just to add, it also depends a bit on the use case. So the pipeline elements are usually for reusing. So if you have a general algorithm you want to provide to different customers, then you can provide a pipeline element that can be used within a pipeline. And if you have your custom logic that you want to use to analyze the data, then there's the function API where you can programmatically, as I showed before, connect to the streams and also deploy those functions into the system.
Yeah. So in case you have any question on that, Alex, please feel free to ask. So I hope that answers your question. So continuing with extending Streampipes in terms of the user interface. So they're we use micro frontends, so which you can use to easily add your own user interface plugin. So that's a very cool technology, because we can just use the Streamapps instance to have additional modules that are authenticated and reuse the business logic and logic of the UI. So for that, we provide a TypeScript SDK for all platform features. So you can use that to develop your completely custom UI, but you can reuse the TypeScript SDK to get pipelines stored in Streampipes, to get data explorer views, to get data and so on. So that really helps to develop your own modules. We also provide some reusable UI components, so that you can ensure that the look and feel of your own custom user interface extension looks like the rest of Streampipes. And there's also a dedicated storage API. So in case your own user interface extension requires some storage for storing user settings, you get access to your own user storage space in the API to store and retrieve such settings. And the example case I would like to show on how to really use Streamers as a custom application platform is our company. So basically, Bytefabrik was founded 2 years ago by the original creators of Apache Streamer. So that's Philipp and me mainly, and 2 other developers. And so what we do is we provide Streampipes support on the one hand, of course, so that companies who use Streampipes can get some professional support. But also we develop a custom-built version of Apache Streampipes that includes some more add-ons for manufacturing companies. So that on top of Streampipes as the IoT data analytics and connectivity framework, we have some ready-to-use plugins for manufacturing companies to track cycle times, output, and so on. And we did that plainly by using the plugin system of Streampipes. So let's say here you get a rough overview of the architecture of our own product, which is based on Apache Streampipes. So Streampipes provides connectivity, data historian, pipelines, so everything you've seen, and also developer tools. And on top of that, we have a product called Bytefabrik Insights, which is really targeted at companies using automated production lines. And based on live data, we have some event and anomaly detection framework that produces some numbers like output analysis. It analyzes cycle time. It analyzes the actual process of products going through the system, and also presents reports of parts that have been produced. And also some other plugins like calculating OEE and maintenance planning and so on. And so our goal was to tightly integrate that with Streampipes. So our product, it's not a fork or something of Streampipes, but it really just uses the plugin system everyone can use to extend Streampipes. And let me show that to you in a second. So when switching to, just one second, when let me open my browser. So what you can see here is like the Bytefabrik instance. So as you see, it quite looks similar to Streampipes, but when we open it, okay, you can see first it has a different look and feel. So Streampipes can also be easily customized to your own corporate identity or so. So that's just a few configurations you need to provide. And what you can see now is basically the modules Philipp has shown before. But there's one more module like Bytefabrik Insights, and that's developed as an extension, which is both like a new UI extension, but also like has its own microservice running as part of Streampipes in the background that extends Streampipes functionality. So what you can see here in that application is like basically data already prepared for manufacturing companies. So what you can see here is an example plant with several stations. So that's an assembly station of gear drives. And first there's a plug joining process. Then the part is being moved. And there are several other processes, a leakage test in the end, a visual inspection. And people can quickly see, okay, which stations cause like more rework, for instance. So, and then you can like click on that. You can see like the station view. You can go through the process, see cycle times in the station, but you can also like quickly investigate process parameters. So see sensor values. In that case, you see leakage values, and it's quite easy to see like deviations from the normal process. And this extension is also like directly integrated with Streampipes. So for instance, you can have links for if you would like to go to the Data Explorer, you can click there, and now you're in Streampipes, which is a core module of the open source solution with the Data Explorer Philipp has shown. But if you go back, you can go back to your own plugin, and it's really tightly integrated using our plugin system. So for instance, also we have a view that uses Streampipes under the hood to store information for every produced part, so that you can see, or companies can see how some part went through the whole system. You can have all measurements here. People can provide that to customers to prove that they have been within the range of the process parameters and so on. So that's like an example how we use Streampipes to extend the system for our own product. And that's basically can be done by everyone. So it's really easy to use Streampipes as a platform for developing your own applications that might completely differ from that what we've shown here. So going back to the slides, I have just one more technical slide on how we use that plugin system to extend Streampipes. So what you've seen is the user interface of called Bytefabrik Insights. Sorry. And so this uses like the TypeScript library to get access to platform features, so like data and results, or also like custom data that is required by the user interface. And we have another microservice running there that uses Streampipes functions to do that event and activity detection in the background and consumes data from Streampipes over the messaging layer. So all data has been previously connected to the PLC, and the microservice consumes it and prepares data so that it can be used by the UI. There's a service discovery framework in the background. So once you start such a microservice, which you can just implement based on a template, and then you also can be sure that the microservice also is properly authenticated and so on. So and once you start the service, it registered in Streampipes. So Streampipes knows there's an additional microservice and can serve the functionality needed by the service here. All right, so the last part is our roadmap. So what are we currently working on as an open source community? So there are three, let's say, main efforts the community is currently working on. The first one is the Python library. So we are still working on extending it because we got quite good feedback on people like data scientists who don't want to care with the stuff of connectivity, of connecting OPC, UA data and so on, who want to focus on their data science task. And so that's quite cool to work with a Python library without having to hassle with technical details of connectivity. Also, we work on improving OPC UIA and MQTT support. So some members from the community have proposed to integrate with Sparkplug, so that's currently being discussed, and we also welcome feedback and people here who would like to help us developing that plugin. And the last thing is that we are currently working on really improving the documentation with our goal to also provide first-class documentation and all the features we have shown throughout that presentation. So if you would like to contribute, there are several ways. So you can, of course, help us developing. So all our code is on GitHub. It's organized as an Apache project, so everyone can contribute. We really welcome people who try or who help us developing, but also who provide documentation, non-code contributions. Of course, you can also use Streampipes. That helps a lot. If you use it and you have feedback, please feel free to provide feedback. We have activated GitHub discussions where you can ask any questions you have, and also help us spread the word about Streampipes so that people know about, and if you like it, that you also recommend it to others. And also if you have use cases that you would like to see supported in Streampipes, these are very welcome also. Or if you have problems with a solution and would like to have something included, just tell us using the community channels. Yeah, so that's the end. So thank you for listening and joining. And if there are any questions, we have a few more minutes, of course, or however you would like to how much time you would like to have to answer your questions. Thank you.
Okay, thank you. So I think we've got one more question from Wilson. So Wilson is asking, how can one get a job with no experience in Apache? I don't know if you can speak to that.
Yeah, so basically the Apache Foundation is like, it's an open source foundation with almost no real employees. So that's all volunteers, completely volunteer driven organization. And so what you can do is, of course, you can volunteer. There's many Apache projects at all kinds of challenges. So you look at the website. So so it's a very good way to learn about not only open source development, but only about development. You can get a lot of experiences. You can get feedback from really experienced developers, people who know how to build large open source software stacks. So that's quite cool to join their mailing list. So Apache is a very open organization. You can follow discussions, you can participate in discussions. So it's really a community-driven way. And so, but directly jobs is nothing that Apache offers, but there are also many companies behind the individual open source projects that also provide like the opportunity to let's say work on open source projects while being paid at the same, or getting paid at the same time. So I hope that answers the question.
Okay, I hope that answers you, Wilson. So we've got another one from Alex. So Alex is asking, is there documentation to implement the plugin system?
Yeah, so there's currently documentation on how to use the software development kit, which you can find on the website. So just browse to the documentation. There are some tutorials on how to implement new data processors, also some on how to implement adapters. So there's also in the GitHub repo, there are a few Python notebooks that show how to run Streampipes functions in Python, how to use the machine learning integration. What we currently don't have is a documentation about how to write your own microservices using this UI plugin framework. So that's what I mentioned in the end, the point where we are starting to further improve the documentation. But if you are interested in that, please use the channels or write us directly. So maybe the email addresses of us are firstname.lastname@Bytefabrik.AI, or use just GitHub discussions or so, and then we will be happy to provide you with some manuals or to prioritize the improvement of the documentation.
Yeah, absolutely. So we'll certainly be also including your contact details on the description of this video. But I think Alex also has got a follow-up question. So Alex has got some questions here. Where are the data stored? What about retention time? Is it configurable?
Yeah, great. So it depends a little bit on your setup, as I said in the beginning. So the messaging layer can be configured. In case you use like Kafka, you also get the possibility to store data for some time between pipeline elements, but the time series database in the background that we use as part of Streamers is an InfluxDB, and you can set the retention time there.
Okay, perfect. So I hope that answers you, Alex. So Raul has got a question. Does this support multiple site deployment?
Multiple site deployment. So basically, of course, you can download it and run it anywhere where you want and install it. And the system itself it supports geographically distributed pipelines. So you can deploy some kind of microservice close to the machine on some edge PC or industrial PC. You can have other microservices deployed more centrally, and Streampipes manages the orchestration in case the network can be reached. So in general, yes. I don't know, Philipp, if you have to add something.
No, I would also say that the individual services are microservices that can communicate with each other, and then it highly depends on the use case you want to realize. So sometimes it makes sense to process the data near to the data source, and sometimes you want the raw data like in the backend or more in the cloud part. But that's something you when you deploy the system, you can decide where the individual services run.
Yeah.
Okay, perfect. Yeah, it seems we've got no questions. I mean, again, so we're going to put the links to all the resources that have been mentioned on this call, and then also the contact details of Philipp and Dominik. In case any of you have got some follow-up questions, you'll be feel free to reach them directly. So maybe I've got like kind of like just one question, which I think maybe you get a lot. And I've already seen actually the differences, but how do you articulate the question when someone asks you, what are the differences between Streampipes and Node-RED, or what are the use cases that you see that could be addressed differently by both tools?
Yeah, so actually we really did get this question several times, and so what I typically say is we try to position Streampipes really for the industrial IoT space. So let's say the use cases Node-RED covers are more broad, and we try to really focus on having great PLC connectivity, having an algorithm library that is tailored at industrial data analytics, but also providing like an end-to-end toolbox for this space, so that you don't need to deploy like Node-RED together with an Influx, together with a Grafana dashboard or so that you have a really easy to use integrated development where user management is integrated, authentication is ensured for this space of industrial IoT. So that's our focus. And on the other hand, to really focus on these non-technical users from a user point of view. So compared to Node-RED, where you in the end also have more, let's say, flexibility, because you can directly work on JSON objects and manipulate JSON objects using the Node-RED interface. So that's something where we abstract in Streampipes. So you don't see like the underlying data typically when building pipelines. So it's really targeted at the non-technical user at the cost of probably less flexibility compared to Node-RED, but with the added value that also people without any programming skills can really easily use data analytics with Streampipes. So that's like our main differentiation point. I hope you also can see that from your experience with Node-RED and Streampipes, what you've seen so far.
Yep, absolutely. I'm looking forward to playing around with Streampipes, and I'm certainly also very interested with what you mentioned about supporting potentially Spark Plug in the future.
Yeah.
That's something also that would be of great interest to me. So I'm really looking forward to playing around with it. So maybe one more question from Alex before we leave. So Alex is asking, how is reporting done? Create a chat report, say in PDF.
Yeah, Philip?
In general, you can like export the data as you showed before in raw data, and also use it, export it as CSV and get it into your Excel, for example. Directly in Streampipes, there's no PDF export right now, so that's something you're interested in. Always you can contact us over GitHub discussions or on the mailing list. However, there's also within our commercially software there we have also the possibility to create such reports and send them to you on weekly basis. But that's something that is focusing on the insights part, which Dominik showed, where all the values are already aggregated, and more focusing on the business KPIs and less on the technical or the data explorer that I showed you before, where you see the raw sensor data. But if that's something that's interesting for your use cases, feel free to reach out to us and we can discuss it on GitHub.
Okay, perfect. So that brings us to the end of this session. So don't forget to subscribe and switch on your notifications. We do this every week. Thank you so much to our guests for such a fantastic presentation. Thank you so much for coming out and sharing your insights with the community.
Thank you very much for hosting and for inviting us. And so thanks a lot for your time. Yeah.
Also from my side,
thanks
a lot for organizing it, and to all the listeners, thank you for participating.
Thank you.